Lake Tahoe has climbed to an elevation of 6,229 feet, the highest level it is legally allowed to reach. At the same time, tectonic stress is intensifying along a fault capable of unleashing a magnitude 7.3 earthquake. Two forces, water and geology, are converging in a way that has scientists deeply concerned. After 5 consecutive years of relentless drought, California's most iconic alpine lake underwent a dramatic reversal. Torrential winter storms and repeated atmospheric rivers dumped historic snowfall across the Sierra Nevada, funneling unimaginable volumes of meltwater into the Tahoe Basin. The rise happened faster than forecasts predicted. What should have marked a triumphant recovery has instead evolved into a serious geological threat. Beneath Lake Tahoe's famously transparent blue surface lies a hidden danger few people think about while standing on its beaches. A massive fault line cuts directly beneath the lake bed. According to researchers, this fault has not experienced a major rupture in approximately 4,000 years, far longer than its average seismic cycle. Now, billions of tons of water are bearing down on fractured rock that has been storing tectonic tension for millennia. Seismologists are monitoring the region non-stop. Sensitive instruments are registering an uptick in small earthquakes. If the fault were to rupture while the lake remains at full capacity, underwater landslides could be triggered instantly. Those landslides could displace enormous volumes of water, generating a tsunami capable of striking shoreline communities in California and Nevada within minutes. The very water that rescued the state from drought may now be amplifying the risk of something far more destructive. The number is precise: 6,229 feet above sea level. This marks Lake Tahoe's maximum authorized elevation, a limit established by a federal court ruling more than 100 years ago. It represents the absolute ceiling, the point beyond which the lake is not permitted to rise. Today, the water is pressing directly against that boundary, with no additional room to expand. Just 5 years ago, the situation could not have been more different. Prolonged drought had drained the lake to historically low levels. Ancient tree stumps, preserved underwater for centuries, emerged along the shoreline. Boat ramps extended uselessly into dry land, stopping far short of the water's edge. Marinas struggled to stay operational. Businesses dependent on lake access suffered as the shoreline receded month after month. Climate scientists openly questioned whether California's water systems would ever fully rebound. Then the storms arrived. Beginning in late 2022, one atmospheric river after another slammed into the Sierra Nevada. Snow piled up at unprecedented levels, with some monitoring stations reporting 237% of average snowpack. When spring temperatures rose, the melt began all at once. Water rushed into the Tahoe Basin in quantities hydrologists had not anticipated. Within a single season, the lake level surged by nearly 4 feet. Water managers reacted quickly, opening dam gates at the Truckee River outlet and releasing the maximum allowable flows downstream. Even that proved insufficient. By early 2024, Lake Tahoe had reached elevations unseen since 2019. The speed of the transformation stunned longtime residents who had spent half a decade watching the lake shrink. Tourism officials celebrated the resurgence. Beaches that had been cracked and dusty only 2 years earlier were once again submerged. Kayakers and swimmers returned. Media outlets hailed the event as a water miracle for California. But beneath the celebration, scientists noticed troubling signals that had nothing to do with rainfall or snowmelt. Seismic instruments positioned throughout the Tahoe Basin began registering unusual patterns. Subtle shifts, small tremors, changes that demanded closer inspection. The drought was over, and the lake had returned to its highest possible level. But something else was happening deep below the water's surface. Something capable of transforming relief into anxiety, and anxiety into alarm. Under Lake Tahoe's serene exterior lies one of California's most serious geological hazards. Known as the West Tahoe Fault, this massive fracture runs beneath the lake bed for roughly 25 miles. Researchers have studied it for decades, and what they've uncovered is deeply unsettling. The West Tahoe Fault is capable of producing earthquakes as powerful as magnitude 7.3. To put that into perspective, the 1989 Loma Prieta earthquake, which devastated the San Francisco Bay Area, registered a magnitude of 6.9. A 7.3 earthquake releases approximately 2.5 times more energy. The damage would be severe. But magnitude alone is not what concerns scientists most. Timing is. Teams from the University of Nevada and the U.S. Geological Survey have extracted sediment cores from the lake floor, examined submerged fault scarps, and analyzed geological records of past ruptures. Their findings point to a disturbing conclusion. The West Tahoe Fault last experienced a major rupture around 4,000 years ago. Based on its slip rate and accumulated strain, it is now considered overdue for another large earthquake. That means 4 millennia of pressure building within fractured rock. 4,000 years of stress accumulating along a fault that will eventually give way. This is not a single, clean break in the Earth's crust. The fault system beneath Lake Tahoe consists of multiple interconnected segments. A rupture in one area could cascade through the network, triggering a much larger event. The result is a web of instability concealed beneath one of the most treasured vacation destinations in the United States. Unlike the San Andreas Fault, the West Tahoe Fault receives little public attention. No blockbuster movies dramatize its danger. Few visitors realize that while they swim or boat across the lake, they are directly above an active fault system. Yet seismic hazard rankings place the Tahoe Basin among the most concerning regions in California. And now, an additional factor has entered the equation. Water is extraordinarily heavy. 1 cubic foot weighs about 62 pounds. At full capacity, Lake Tahoe holds roughly 39 trillion gallons of water. The resulting weight is almost impossible to comprehend. Billions of tons pressing downward continuously. This immense load does not rest on a uniform slab of solid rock. It presses into fractured bedrock, seeps into cracks, and increases stress along fault planes. When such weight sits atop an active fault, it can influence seismic behavior. This phenomenon is known as induced seismicity, and it is well documented. Large reservoirs have been linked to earthquakes around the world. In 1967, India's Koyna Dam Reservoir triggered a magnitude 6.3 earthquake that killed 180 people. Lake Mead, formed by Hoover Dam, has produced hundreds of small earthquakes since it filled in the 1930s. China's Zipingpa Reservoir has been studied extensively for its potential role in the devastating 2008 Sichuan earthquake that claimed nearly 70,000 lives. The mechanism is twofold. First, the sheer weight of water adds vertical stress to fault systems already under horizontal tectonic pressure. Second, and more critically, water infiltrates rock fractures, increasing pore pressure. This reduces friction along fault surfaces, effectively lubricating them and making it easier for stored strain to be released suddenly. Lake Tahoe is now at maximum elevation, maximum mass, and maximum pressure. All of that force is bearing directly on a fault that has been accumulating strain for thousands of years. Scientists understand what this combination represents: elevated risk. Seismic instruments are confirming their concerns. Monitoring stations around the Tahoe Basin have detected a rise in small earthquakes along the West Tahoe Fault system. Tremors measuring around magnitude 1.9 have been recorded in recent months. These events are far too small for people to feel, but seismographs capture every vibration. To the public, such tremors might seem insignificant. To seismologists, they can be meaningful. These micro-earthquakes may represent warning signs, small adjustments along a fault under increasing stress. Historical data shows that many major earthquakes are preceded by increases in minor seismic activity. The 2011 Tohoku earthquake in Japan followed a similar pattern. So have numerous other large ruptures worldwide. Researchers now monitor Tahoe's seismic activity around the clock. They analyze event frequency, depth, and location, tracking changes week by week. What once appeared normal now stands out against the backdrop of unprecedented water pressure. Interpretation remains challenging. Small earthquakes can signal an approaching major rupture, or they can relieve stress and delay one. Sometimes they mean nothing at all. Earthquake prediction remains one of science's greatest challenges. Still, experts agree on one point: the conditions at Lake Tahoe warrant extreme vigilance. An overdue fault, maximum water load, increasing seismic activity, Each factor alone would raise concern. Together, they cannot be ignored. If the West Tahoe Fault ruptures while the lake remains full, the earthquake itself may only be the beginning. Lake Tahoe's underwater topography is steep and dramatic. Depths exceed 1,600 feet, with near-vertical walls in places. Massive slopes of loose sediment cling precariously to these gradients. A powerful earthquake could destabilize them instantly, triggering enormous underwater landslides. When millions of tons of sediment plunge into deep water all at once, they displace vast volumes of water, generating tsunamis. Geological evidence confirms that this has happened before. Sediment studies reveal ancient landslide deposits, including the massive McKinney Bay event, which moved an estimated 12 cubic miles of material. Modern simulations suggest that a similar event today could produce waves 30 feet high or more, racing across the lake at speeds approaching 100 miles per hour. Communities along the shoreline would have almost no time to react. Lake Tahoe is only 12 miles wide at its broadest point. A tsunami generated on one side would strike the opposite shore within minutes. Unlike ocean tsunamis, which may provide hours of warning, a lake tsunami offers virtually none. The enclosed basin worsens the danger. Waves would reflect off the surrounding shoreline, rebounding repeatedly and striking multiple times. Approximately 55,000 people live in the Lake Tahoe basin year-round. During peak tourist seasons, that number swells dramatically. Summer weekends can bring more than 100,000 visitors. Ski season fills resorts and casinos with thousands more. On holidays, the population can triple. These people would have minutes, if that, to understand what was happening. Evacuation routes are limited. The lake is surrounded by mountains, accessible by only a few narrow highways. During normal conditions, these roads already clog with traffic. In an emergency, gridlock would be inevitable. Jurisdiction complicates matters further. The lake spans 2 states and 5 counties. Multiple agencies would need to coordinate instantly during a crisis unfolding in real time. Yet there are no tsunami sirens, no marked evacuation zones, and little public education regarding the seismic threat. More than $15 billion in property lines the shoreline: luxury homes, historic resorts, marinas, and commercial districts. All of it built on the assumption that the lake is purely a source of beauty, not danger. Inside monitoring stations scattered around the basin, instruments record every tremor, every shift. Technology has never been more advanced. Earthquakes too small to feel are detected. GPS stations measure ground movement down to millimeters. Satellites track subtle surface changes invisible to the naked eye. But one limitation remains unchanged. Earthquakes cannot be predicted. Scientists can assess risk. They can identify warning signs. They cannot say when a fault will fail. The consensus among experts is uncomfortable but clear. The West Tahoe Fault will rupture. This is not speculation. It is geological inevitability. The only unknowns are timing and magnitude. Above the fault, life continues. Tourists photograph sunsets. Families swim. Homes are built. Beneath the surface, pressure continues to accumulate. Lake Tahoe has reached its limit. The water is calm. The surface remains impossibly blue. But deep below, the earth is restless. And the question facing scientists grows louder with each passing tremor. Has the fault beneath America's most beautiful lake reached its limit too?